Okay, so in this video, we're going to be looking at how you can construct the equation for your trigonometric portion of your graph. So yours will be a little different to mine depending on what your data looks like. There is another video as well from last year that you could use to potentially help you decide what to do with your equation. This is just how I would solve for the form that I've got over here. Okay, so the first thing that we need to do, we need to talk about what type of equation I'm going to be using. So if I have a positive sine graph, it starts in the middle, goes to a max, down to a min, and then back to the middle. If it's minus sign, it's going to go the reverse way. So typically if there's a minus, it's trying to get to negative first. So it's going to go down to the min, up to the max, and then back to the mid. If it's a cos graph, a positive one will start at the top of the graph, a negative one will start at the bottom of the graph. So if I'm looking at what shape I've got over here, if I think about what this would look like, I'm going to say that the shape of it would be something like that. So this point here is going to represent the middle of my graph, whereas this point down here is going to represent the minimum of my graph. Okay, so I'm going to say then that the type of graph it is most likely a minus sign graph. Now, I know there's probably a couple of you sitting out there saying, but over here, where's my pen? If you projected this over to the line, wouldn't that hit and make it more of a positive cos style graph? And yes, potentially you're right, because the only difference between a sine and a cos graph is the phase shift. So I'm going to correct that distance that's been moved by employing a phase shift to make it work out nicely. Okay, so we've got our type now. Next thing we're going to do is we're going to state our D value, which is the middle of the graph. Okay, so if I look at that point there, I've said that that's the middle of the graph. Now, that is when time is equal to 9. Now, you might notice that I've accidentally cut 10 off this. I'm just going to use the data that I've got in front of me. Obviously, if this was my assignment, I'd go and get a better picture that had the 10 in it. Okay, so that's the one I'm going to use. I'm just going to cross out the 10, so I know not to use that one. So the middle of our graph is going to be equal to 2, 9, 9, 1, 2, 3, 4, 5. Okay, next thing I'm going to do is work out the amplitude. Now, the amplitude is the distance that it takes to get from the middle all the way down to the minimum of the graph. So I can see here that the mid amplitude equals, the middle of that graph is 2, 9, 9, 1, 2, 3, 4, 5, and I'm going to subtract the minimum of the graph. So that's going to be down here. I'm going to take my lowest point as this one, 2, 6, 1, 2, 3, 4, 5. Now, when I subtract those two numbers, I'm going to work out that the amplitude of this thing is, I'll just get my calculator up. So my amplitude of this, you can see I've already punched that into the calculator previously. So that is 2, 8, 2, 1, 2, 3, 4, 5. Okay, so now I've got D, I've got A. Let's find B. So B in this graph is going to be equal to 2 pi on our period. Now, the period of a function is how long it takes to do one full lap of the unit circle, or in other terms, it's how long it takes to go from the middle to the max, down to the min, back to the middle. Okay, that's typically for sine graphs. For cos, obviously, you can see you just want to pass through the max, the min, and then go back to the max. So you always want to finish where you started. Now, if I think about this graph that I've got here, my period, or the time it's going to take me to do one full lap. If this is the middle of my graph, there's one portion over here that I've left out. There's another portion here that I've left out. There's another portion here. So currently, between 9 and 20 represents a quarter of the period. So if I want to find out the period, I need to do 4 times 20 minus 9. That's going to work out the distance between here and here. And then timesing it by 4 will give me one full section of the graph. So when you punch that into your calculator, 20 minus 9 is 11, times 4 will be 44. Now our b value that's getting substituted into our equation, I can do 2 pi over 44, meaning that b is equal to pi over 22. Now the last thing that we need to solve for is our phase shift. So c is what we use as our phase shift in our equation. It's important to note that this is in brackets. If you don't have brackets, I'd have to do b times x and b times c. So if you're identifying your phase shift, it's in this form where it's inside the brackets. So here, sorry, our phase shift is how much you have to move it back to get it to start at the beginning. So here, if my graph starts here when t equals 9, then to get it to start over here at 0, I have to move it back 9 places. So I'm going to go over here. C is going to be equal to negative 9. So now I've got everything that I need to be able to state my equation. So y equals a, which is 2, 8, 2, 1, 2, 3, 4, 5. Sine, now it's minus sign, so the minus is going to get moved to the front of that graph. So now it's minus 2, 8, 2, all the zeros, sine, bracket, pi on 22, close bracket, x minus 9, plus our d value, 2, 9, 9, 1, 2, 3, 1, 2. Okay, so next thing I'm going to do, I'm going to try and copy and paste this portion so that I can substitute that into Desmos. I don't know if that'll work though. Let me just click around until I find it. Here we go. So let me turn off some of these. So this one here, that green portion, is where I've entered it into the thing. So I set my domain so that you can see what's happening. I've then put in my function, and then I've got the rest of my graph like that. Okay, so if I want to get that table, no, it's just going to enter as an elements list. Let's see if I can just copy and paste this. If it doesn't work, it's okay. You don't have to show all of them together. No, it's not going to work. I could copy and paste it from my Word document, but that's not open at the moment. So what I would be wanting to get from this is that equation, and then I can talk about how it's fitting this data here, whether I've done a good job of creating it or not. But remember, this is not about fitting data. This is about using calculus. So I don't want to see 2 pages about regression scores. You don't even need to mention the regression scores. What we're really looking for here is that you fitted the data with a model.